Hey folks, in this video I'm going to quickly show you how you can block or allow webbot and agent traffic from accessing certain endpoints on your API using HTTP message signatures and a new policy that we've released for Zuplo that allows you to verify those. Let's get started. Over here on the screen I've got my root editor for the Zuplo API gateway, which has a very basic API in it. It has one endpoint, v1/photos, and what this does is return a JSON response of a list of photographs. So I'll show you what that looks like. This is it. On the left I've got my terminal, and if I do npm start over here, what this is going to do is start running a script that acts like a bot. It's going to make a request to this endpoint for photos every 10 seconds. And you can see at the moment it's getting 200 OK back from the API, which you would expect because there is no policy whatsoever attached to this endpoint. There's no authentication checking. There's nothing stopping this completely open endpoint from being hit by that particular bot. Normally you would have more policies in place on an endpoint like this, probably some kind of authentication, also rate limiting, but for the purposes of this demonstration, I'm just going to leave it completely blank. And then I want to stop this script from being able to access this endpoint, and I'm going to do that using the new webbot auth policy. You can see here it has a couple of options to allow unauthenticated requests. It has an allowed bots list, so you can populate this with a list of names of bots that you want to pass traffic through, blocking unknown bots, and also a directory URL, which I'll get to in a little bit, which speaks to more of the cryptographic side of HTTP message signatures. So if I add this as is right now and then click on save and redeploy the API, what you're going to start to see here is the requests are going to start to fail. They're going to get a 403 forbidden the next time it runs, because now it's actually checking whether or not this bot is in the allow list, which it isn't. You can see in the response, friendly-bot, which is the name of the bot that we have here, is not in the allowed list. So all of these requests are now getting blocked. So let's take this name of our bot and add it in here so we can allow it to make those requests again. I can add that to the allowed bots list just like that. And you can add any bot names in here. So you can add Googlebot to this, you can add Yandexbot to this, you can add Bingbot here. And of course, this doesn't work just for web scrapers. For search engines, it will also work with LLMs and agents and anything that's making a request using HTTP message signatures effectively. So this name is coming from that particular signature. So if I click on OK, click on save and redeploy the gateway, in just a couple of seconds we are going to get 200 OK back from this, because now it knows that friendly-bot is OK to allow traffic for, so we get the response once again. Now, this is fine, but there are a couple of elements here that are being missed out. We're not really doing as much as we could be with all of the cryptographic information we have here on the left. So really everything that's in this HTTP message signature is not really being used to its fullest extent, but we can change that and make it so that very much, if it doesn't match this cryptographic entity that we have here, it's going to start to block things once again. So what I'm going to do now is head back to this policy. We need to specify a directory URL. The directory URL looks like this. It's basically a list of the cryptographic signatures, the public keys for these specific bots. So for example, Googlebot or Bingbot, or in the case of our friendly bot, we need something that looks like this so that we can map this to that particular policy and then check it against the signature that's making the request. Now at the very top of this script, what I did is actually have it generate that public key. So this is the public key in that format for friendly-bot. What I need to do is put this somewhere that can be read by the directory URL key. So this needs to be the URL of something that's going to return a JSON response with that information in it. And so for this, I'm going to use mockbin just for the sake of being able to pass this back relatively simplistically. So we'll add this in here and create that bin. And then if I show you this, you see that we get that response back in the format that we're looking for. So we can use this now as the directory URL value. We put it in, we click OK, we click on save, and we redeploy. Scroll back down to the bottom, we see that those requests are still coming through. There's another one. So that's okay, but nothing really changed. So let's see this in action now with it actually blocking, because it's checking the cryptographic information that we've put in that directory URL. So if I stop this script and start it up again, what it's going to do is it's going to regenerate that public key. So it'll be different now. And you can see that because it doesn't match what we have here in our directory URL, which is inside of this policy, and what's being checked against the signature that you can see on the screen, they don't match anymore. So it's now starting to block that traffic once again. So we have a new public key. We'll go back to mock bin and create a new bin this time. It's worth noting that you can put this wherever you like. I'm just using mock bin for demonstration purposes. This can also live at a specific URL that you can specify as part of the message signature that you send, so that the verification that's happening can actually read that, know where to go to look for that key and check it against the particular value that you specified. So you don't have to necessarily do it the way that I'm doing it here. If you're building a bot, or you're building an agent, or you're building something that's going to be doing that, you will specify where the public key lives. And that's one of the best ways that you can make sure that anything that's checking the signatures that you're sending is able to do it against your public key, is to specify it. So then if we head on back and then we change this, you can see the responses are still failing on the left because the signatures don't match. And once we change this and redeploy it, it's going to have the signature for this particular bot that's running here now. And once it deploys and checks against it, they should match again. And we're going to see verification happened, 200 OK came back, and our API is once again accessible by this bot because we've cryptographically checked that everything that it's trying to do is valid. So there you go. That is how you use the webbot auth policy inside of Zuplo to block or allow different bots and various other LLMs and agents from accessing certain endpoints using cryptographic HTTP message signatures.